Hi, everybody, and welcome back. Today, we're going to be looking at immunity. Now, in this video, we are going to cover the entire immune system reaction, moving from the first line of defense all the way to the third line of defense. And it's important to know that when we speak about immunity, there is more than one kind of immunity. And so essentially, what we're going to focus a lot on is your acquired immunity. And essentially, what that is the immunity that you have developed during the course of your life. Now, you get passive immunity, which is a type of immunity where someone or something else has provided you with the defense against the infection. And that's what immunity is all about, providing protection against foreign substances or pathogens from entering the body. Now, a natural way to get passive immunity would be through the transmission of like antibodies from a mother to a baby via breast milk. And I want you to know that passive immunity is very short term, it's not long, it doesn't last forever. On the other side, you can also get artificial passive immunity, which is when you are given a serum medicine. Often, what happens is, for example, with tetanus, um, people who have stepped on a rusty nail are exposed possibly to tetanus, and instead of giving them a vaccine, we give them a serum of antibodies which allows them to fight off any kind of infection that may already be there. Now, passive immunity is short-lived, and it doesn't require actual exposure to the pathogen in order to develop an immune response. In other words, someone else is giving you antibodies. The one we're more familiar with is active immunity, and that is when you are exposed to an infection and you develop a response to it. You can also use active immunity for when you get a vaccine. And so there's two ways that this can happen. The first way, the natural way, is let's say you're exposed to some kind of pathogen like a virus, perhaps something like chickenpox. You then develop antibodies for chickenpox, and the next time that you're exposed to it, your body can fight the infection better and faster. The artificial way is the vaccine way. And there are multiple kinds of vaccines available today, but essentially what happens is you're injected with some form of the pathogen, whether it be a dead pathogen or a piece of the pathogen, and your body remembers what that pathogen looks like. So the next time, if you are exposed, you don't fall ill. So, in order to be a successful immune system, you need multiple lines of defense. And our first line of defense is non specific. In other words, it doesn't target a specific pathogen, it doesn't prevent a certain kind of bacteria or a certain kind of virus from entering. Essentially, it can't tell the difference between what's infecting you. Instead, it is the protection that we have on the surface of our bodies. And so this means it's not in the tissues and it's not in the bloodstream. In other words, these are the things that you have on the surface of your body that prevent substances from going into your tissue or going into your bloodstream. Now, in the picture here, we have some examples. Some non specific surface immunity would be something like your eyes and the tears that you have. Your tears have antimicrobial proteins in them, which prevents bacterial growth. You also have in your respiratory tract and in your nose, you have a mucus lining. Now, the mucus lining is really important because often pathogens get stuck in the mucus themselves and they can't actually get into your bloodstream or into the tissue. And lastly, the most important one in terms of the first line of defense, because it's the biggest one, is your skin. Now, your skin is a physical barrier, but it also has chemical barriers as well. And that is, for example, sweat. Now, sweat changes the pH of your skin. It makes your skin a lot more unhospitable to pathogens for them to grow. And so often what you find is that the surface of your skin is a little more acidic, and that's because bacteria and fungi, they struggle to grow in a more acidic environment. And that's what you want to maintain as your first line of defense. But what happens if a substance like a pathogen gets beyond your skin? And that brings us to the second line of defense. So, our second line of defense is a midway between being in the tissue, but not actually being in the actual blood. And so if you look at this photo, this alongside, this is exactly what I mean. What we're looking at here is we have a wound of some kind. Something has pierced the skin here. Perhaps it is a nail or something sharp, even a splinter. And you'll notice that it's not in the bloodstream. So the bloodstream hasn't been broken. There's no blood. You're not bleeding. Think of something perhaps like getting a splinter in your skin. You're not bleeding, but you've still pierced the skin. So we're in the soft tissues now. And a very common reaction associated with the second line of defense is what we call the inflammation response. Now, the inflammation response literally means swelling and fever. And it's a non-specific response. And remember, non-specific means that it doesn't matter if this is a virus or a bacteria, it will affect you the same. Now, there are other things associated with inflammation besides swelling and fever, and that's also some antimicrobial proteins, which I'll discuss now, where essentially these are substances that draw out the white blood cells and bring them closer to the infection. So, let's say, for example, in our photo here, we have a splinter stuck in the surface of our skin. What does our body do to prevent any of the pathogens that are on that little piece of wood or in that little piece of splinter? What is our body doing? So, what you notice here is that we've made an incision now into the skin. And you'll see that on the surface, there were bacterial cells. Now, what happens is when you start an inflammation response, there are these tiny little antimicrobial proteins, which is what you can see here. It's these red circular structures. And those are the antimicrobial proteins that are released by the skin to warn your immune system that there is something in the skin and in the soft tissue that is possibly carrying a disease. And so, what does that do? It attracts these really large white blood cells, which we call phagocytes, and they are attracted to the area. And what they do is they squeeze through the spaces in the capillaries. They make their way into the soft tissue, and then they digest and destroy any foreign pathogens. Now, if we were to look at what happens in terms of the order of events, once you have damaged the tissue, you are going to produce a chemical called a histamine. And I'm sure you've heard of medication called antihistamines, which essentially are prescription medications that prevent swelling, inflammation. And if you have hay fever, that's also what you can take it for. And so, what a histamine does is it induces swelling, it induces heat. And so, what that does is it also attracts the phagocytes to this area, and it makes your blood vessels swell and it makes them more permeable. Now, you want that because number one, you want the swelling because the swelling leads to more blood flow to the area. More blood flow to the area means more white blood cells. And the second thing is you want the permeability because if the skin is um, damaged, you want more blood to rush to the area, and you want the white blood cells to be able to squeeze through the empty spaces and get into the bacterial cell. Now, how do these big white phagocytes destroy your pathogens? Well, they do this through phagocytosis. So let's zoom in on what exactly is phagocytosis. So, phagocytosis essentially is when a phagocyte, which is a really large white blood cell, is going to engulf some kind of foreign particle. In this picture here, we have a bacterial cell. And so what happens is the phagocyte will approach the bacterial cell and it will engulf it. In other words, it will trap it inside its cytoplasm. So it moves towards it and it surrounds it. Then what happens is that your phagocyte is going to isolate it on its inside. It's going to keep it there. It's going to make almost like a membrane around it to make sure that the bacterial cell can't escape and it can't be left behind anywhere. And then finally, what the phagocyte does is it uses its lysosomes. Now, if you remember what a lysosome is, it is a temporary vacuole that contains digestive enzymes. And those digestive enzymes will degrade the bacterial cell, break it down into its smallest components, make it essentially harmless. And once the phagocyte is done with that, it can absorb anything if it wants to keep it, but it can also remove any excess pieces of the bacteria cell as essentially cell waste, and it can be excreted out of the phagocyte via exocytosis. Now, both of the lines of defense we've just done are non-specific. So it doesn't matter what infects you, this is how your body responds. But what happens if it's a very specific pathogen, a specific virus? And what does your body do if it's now in the bloodstream? Because up until this point, this has all occurred on the surface of your skin or in the soft tissue, but not actually in the bloodstream. Well, now we're going to look at the third line of defense. So the third line of defense is comprised by very, very specific cells. Previously, we had non-specific responses, and this is a very specific response. And there are two kinds of cells involved in the third line of defense. The first one are our T lymphocytes. Now, our T lymphocytes come in three varieties that we need to know of. And the first kind is what we call a helper T cell, also known as CD4 cells. And these are really important because what they do is they begin your immune response. And so, for example, if you have an infection that's now made its way into your bloodstream, these cells, the CD4 or helper Ts, they are going to be the alarm bell ringers. They're going to say to the body, we are infected, we need help. And besides calling other T lymphocytes, which I'll get to now, they also call the help of B lymphocytes. Now, we'll get to B lymphocytes, but B lymphocytes are the antibody producers. So we have two assistants happening at the same time. We have the helper Ts calling for help from other white blood cells, and they are also calling help from the B lymphocytes. Now, the second thing that can happen is we can also call for help from what we call killer T cells. Now, killer Ts, as their name suggests, destroy infected cells, but this is important. They destroy host cells. In other words, they actually destroy your body's cells, the ones that are infected, though. You see, the problem is that once a virus is inside of your cell, your body can't actually tell that that cell is sick. You need a special cell to identify that that tissue, that cell over there is infected because viruses hide inside your cells and your body doesn't know that it shouldn't be there. And so when we speak about killer Ts, I want you to know that they target specifically viruses only, or they can also target your own cancer cells because they're going to be the ones looking out for cells that aren't behaving like they should. And that's what killer Ts do. And so to have a look on the left-hand side here of how T cell activation works, let's have a look at exactly how the response begins. And so, first of all, we have a virus. Now, viruses, if you remember, are going to live inside your cells. They spend a very short period of time outside of your cells. So now we have a problem. The cell is infected. Now, remember, your body doesn't necessarily know immediately that that cell is infected. So, luckily, we have T cells. Now, these are the CD4 cells that are doing this. So, this is your CD4 cell. And the CD4 cell is starting the immune response. It's calling for help. How does it do that? Well, that's what these cytokines are. It's basically a chemical message to say, hi, we need help. Please come to this area. And so now we've activated the T cells. Now, the T cells undergo replication. And an option of that replication is to produce and to call killer Ts. And so what you have here is a whole bunch of killer T lymphocytes showing up, and what they're going to do is they essentially feel around and they use their external proteins, these little pieces that stick out the side here to determine whether or not a substance is a foreign particle or a foreign or infected cell. And so what they actually do is they touch the surface of a cell and they go, this doesn't look right. There's something inside of here that's changed this cell's chemistry. And what the killer T's will do is they will destroy that infected cell. Then we can cue the phagocytes. The phagocytes, as we know, are almost like the cleanup crew. They'll go into an area, they'll absorb damaged particles, they'll absorb pathogens, and they'll remove it from your system. Now, something that I want to explain as well is, well, then how do we know what does and doesn't belong in the body? Well, there are substances called antigens. And essentially, what they are is on the surface of every single cell within your body, there is the cell membrane, and sitting on the cell membrane will be some antigens. And basically, they're like these little proteins that sit on the outside of your cell that say, I belong here. I am from this body. And through these little antigens that sit on the surface, your body knows, okay, these cells belong here. This is the shape of the body's antigen. We know that this is not a foreign invader. But now here's the problem. If the foreign invader's antigens don't match our own, that's when the body recognizes it as foreign. So let's say, for example, that this cell that I've drawn here is our own cells. Let's say we had a virus cell infect us, but now its antigens on the outside are a different shape. And that's how the body tells that that foreign invader is a foreigner. It knows what our antigens look like. And because they are not the same and they don't have the same shape, as you can see, this is what our antigen looks like. This is what the virus's antigen looks like. Because they don't match one another, you will see a response to it. And that is how, if we look over at our diagram again, that is how the T cell knows whether or not it's a foreign invader. You can see that it's touching this infected cell. And when it touches the infected cell, it notices that there's something wrong with the antigen. What that actually notices is that if I put one of the virus's antigens inside our own, this little triangle, it notices that that's different, that that shouldn't be there. And now the killer T's know that these cells are infected by this virus. And so that's how we know. Another way we know is that if this virus that was just floating around inside of us, if it was this one over here, if it just floated around, phagocytes can also tell the difference. But unfortunately, phagocytes have to touch the outer area first to know if it's a foreign invader. Now, the third kind of T lymphocyte that you can get is a really important one. And it's there because you eventually have to stop the immune response when you are getting better. These cells are known as the suppressor cells, and they are a type of T lymphocyte that effectively does exactly as the same name suggests. They stop the response. And that is because your immune system can actually be negative to you if it continues. Because sometimes what happens if immune response continues, it can drain you of resources, it can make you weak, it can essentially allow you to get sick again by another infection. So you want to eventually stop the immune response. We finally need to look at B lymphocytes. Now, B lymphocytes are the cells that are called to assist the immune response, and they are called, if you remember, by our CD4 cells, our helper cells. And those helper cells call the B lymphocytes in, and what happens is the B lymphocytes can recognize an infection via the antigens. Remember, antigens are the proteins on the outside of the cell membrane that tell your immune system, yes, I belong here, or no, I don't belong here. And how B lymphocytes are different to T lymphocytes is that B lymphocytes can destroy both viruses and bacteria, whereas killer Ts can only destroy viruses inside of the host cell, and also killer Ts, remember, do cancer. Now, B lymphocytes, on the other hand, well, they have the ability to do viruses and bacteria. And how they do this is they essentially transform into a super producing, very specific response cell called a plasma cell, which I'll explain now what that is. Or some of those individuals will become a memory cell. And as the name suggests, it is the way in which our body remembers infections. So let's go through the step by step process with the diagram about how B cells are activated. So let's say, for example, there's a virus. It has now infected a healthy cell, and it can also be floating around in the bloodstream. So it doesn't have to be inside of something. And this is what bacteria would do. The bacteria would be floating out in the open. And what happens is the CD4 cells, the helper Ts, have called for assistance, and the B cells show up. And what they do is they determine by looking at the antigens on the surface of the cell or the surface of the bacteria that that pathogen doesn't belong there. And now it knows these are viruses or these are bacteria. I need to remove them. And so what happens is they send out an alert, which are those cytokines. It's basically a chemical message, and it alerts all the other B lymphocytes that were already on their way to activate. So, in other words, it's like whoever gets there first, because CD4s have called them to come and see, we're now sending out a response to all the B lymphocytes saying, there's a virus here, there's a bacteria here, this is what it looks like, and now you need to respond. And so we've got two options. The first option is you make a plasma cell. So that's this option down here. It's not labeled. I'm just going to write here plasma. And so a plasma cell is a really important cell because it is a type of B lymphocyte. And so we started off as a B, and now we've turned into what we call a plasma cell. A plasma cell is the cell that makes antibodies. So our plasma cells have shown up. That's step one. And they've now identified that there is a foreign invader, and they are going to start producing these antibodies that we've spoken about. Now, these antibodies must match the antigen of the pathogen. Remember, those are the structures on the outside. And what exactly is an antibody? Well, an antibody is a protein, and they generally come in a Y-shaped configuration. So the protein looks like the letter Y. And essentially, that one antibody can act in multiple ways to destroy the infection, to make it easier for the infection to go away. And if that's the antibody, then if this was our bacterial cell or or our virus, on the outside there are its own antigens. And if you remember, our body is not going to be able to tell that those are ours. It's going to be able to say that's a foreigner. We need to get rid of it. And so what happens? The antibodies, they can fit in on this space, and they label it as a foreign invader. Now, this area that they connect into, they are going to remember it in future. So they're going to remember this shape over here the next time there is an infection. But let's go through how antibodies actually destroy a foreign invader. So antibodies are going to do some of these following things. First of all, what they're going to do is they are going to burst the bacterial cell. So the antibodies can get stuck on the outside of the bacteria. It makes the cell wall very weak, and the bacteria bursts. It can also make it easier for phagocytes to find them. So it's almost like a label to say, hey, immune system, these bacterial cells are not supposed to be here. I'm like a little label, a little flag to say we need to remove you. Another thing that antibodies can do is they clump pathogens together, and this just makes it easier, like a cleanup. If you want to get rid of everything, you want to sweep everything together and make it all stick together. And so antibodies can do that. And so antibodies stick to each other and they clump the pathogens together, making it easy for the phagocytes to come in and just engulf engulf and destroy a big collection of them. And lastly, what they can also do is they neutralize toxins. Now, certain bacteria produce a toxic chemical, and when your body needs to respond to that, they're not just responding to the bacteria, they must also respond to the chemical that's being made, and that's ultimately probably going to make you sick, and maybe even lead to death. So antibodies don't just respond to a physical bacterial cell or viral cell, it can also respond to a substance that they make. Now, once we've made the antibodies and we're destroying the invader, we must remember the invader for the next time that this could happen. And that's the second option. So in activation, we can also make B memory cells. And these are your immunological memory cells. They're going to remember the infection the next time. And these are the vital ones for when we get vaccines. When we get a vaccine, we are essentially doing this whole process, but with a weakened virus or a weakened bacteria. And essentially, we want to remember it the next time. And so, what happens is our body makes antibodies, it makes memory cells, and those memory cells will remember that infection for the next time you may be exposed. So, to summarize that, our memory cells maintain the memory of the pathogen's antigen. And so, remember, every pathogen has a specific antigen, it's like a shape of the protein. And so that the next time affection occurs, we have a faster response. Now, I don't know if you know how long responses are, but generally they can take from anywhere from 5 to 7 days before there's a full response. And by that time, you're feeling very, very sick. If, however, you have had this disease before, or you've had a vaccine, you often won't even feel any symptoms of being exposed because your body will have the memory cell and it will automatically start making the antibodies. So we don't have to wait for the CD4s and we don't have to wait for the B lymphocytes to show up, identify the foreign invader, then turn into a plasma cell, then make antibodies. We just literally go straight from memory cell, identifies the foreign invader, makes the antibodies. And we can see that if we look at the diagram, here is our plasma cell producing our antibodies. Those antibodies get stuck on the outside of our infection. In this case, it's a virus, but it can be a bacteria as well. And you can see the cleanup crew, the phagocytes, they move in and they engulf and destroy any leftover cells, materials that need to be removed. So let's do a final terminology recap. So pathogens. Pathogens are substances that cause diseases. Think virus, bacteria, protist, or fungi. Now you have lines of defense in your body. Your first line of defense is mostly made up of your skin and your mucous membranes. Remember, that's a physical barrier. It's non-specific and it protects you on a variety of substances getting inside of you. But what happens if the substance gets into your skin, but not in your bloodstream? And that brings us to the second line of defense. You can have inflammation, which is swelling and fever, and you also make your blood vessels more permeable to blood and white blood cells moving around. And you can also produce antimicrobial proteins. Now, these proteins can be secreted onto the surface of the skin, or it can be secreted in the actual soft tissue. And an important substance that calls the immune system to your skin and to make sure that nothing's moving into the bloodstream are called histamines. And histamines attract phagocytes, and phagocytes essentially destroy any pathogens, either the actual cell or bits and pieces of the remains of their cell structure. Then we looked at specific immunity, which is the third line of defense. And we have helper Ts who alert the body that you have been infected. We have killer Ts who destroy viruses and cancerous cells. And remember, these killer Ts specifically target host cells. So, in other words, they kill your cells that are infected. And then we went on to B lymphocytes. And B lymphocytes can produce something called a plasma cell. Plasma cells then produce antibodies, and antibodies match up with a specific pathogen, and that pathogen's antigen will tell us they belong or not. And last but not least, memory cells. Memory cells are cells that we keep for sometimes months, and some we keep for years and our entire life, and they will remember the infection so that the next time, if we are exposed, the immune response is faster. I hope that you found this video useful, and I will see you all again soon. Bye.